Hello, this is Ruth Guthrie, and this week we're going to talk about issues related to project management. I've got three cases for you to consider when we're talking about project management. The first occurred a while ago, and it was when IBM was redoing the software for the Federal Aviation Administration. In 1994, Gary Stix published the article Aging Airways in Scientific American, and it talked about the project and what trouble it was having and how expensive it was. The problem was that the air traffic control system was very old and it needed to be replaced. The existing machinery for the system wasn't maintainable, right? Technology marches on, and they had old machines that they no longer even had parts for. There was an increase in traffic, many more planes in the sky and landing, and they needed to support new technologies. So in 1982, it was expected to be an 11-year program and $12.6 billion redesign of the ATCS. By 1994, it had ballooned into 150 different projects, costing $36 billion by 2001. Today, it's still a multi-billion-dollar problem and not expected to be complete until 2025. In a recent Information Week article, the same problems that the project had in 1994 continue to be problems today. The second mini case I'd like you to think about, and maybe you've already heard this or read this in the Times a couple of years ago, the LAUSD payroll crisis. So what happened was Deloitte Touche was putting in SAP payroll system for LA Unified School District. And LA Unified School District has many teachers, and they have different contracts and complex labor agreements. And it was a very complex system, and SAP is a very structured, rigid system. So there might have been a mismatch putting in off-the-shelf software to meet LAUSD payroll needs. At the beginning, it was a $95 million project, and by the end, it was expected to grow to $210 million. When the system went live, this is what really hit the news: teachers with no paychecks. Some teachers were overpaid. Many teachers got no pay at all, and they couldn't even pay their mortgages, and banks were foreclosing on these poor teachers. And then, if that isn't bad enough, ugly finger pointing went on, and the people at Deloitte were pointing their fingers at LAUSD and saying they didn't do this and this and this, and LAUSD said, wait, they're abandoning us, this system doesn't work, they took all our money and nothing works. It was really very ugly and very publicly talked about, and it took many years to fix the problem. And just recently, IEEE published an article that said the payroll problems are fixed, but that is a very long time to finally iron out the bugs of installing SAP for LAUSD. This last mini case is something you've already read. Chris Kanakaris reported on the Air Force massive ERP project raking up $1 billion in costs in computer world in November of 2012. The project cost $1 billion since 2005 and hasn't yet yielded any significant military capability. As the project moved along, the writing was on the wall, and it looked like it would cost $1 billion more before it could be used, and it would take until 2020 to be deployed. So the project was terminated. But one question that Krigsman, an IT failure expert, asks, and it's reported in this article, is why did it take the Air Force $1 billion and almost 10 years to realize that this project is a disaster? What kind of planning process accepts $1 billion of waste? Because that's really what it is, $1 billion of waste, $1 billion spent, 10 years of time, and nothing to show for it. There are plenty of examples of projects that fail, just as there are plenty of examples of projects that succeed. In general, clients aren't super happy with IT systems development, and the projects in general are overrun, late, failures like the three systems we just spoke about. There's an IT backlog that can't be filled, and the users might be very dissatisfied with what the outcome is. An IT backlog means that there's plenty of projects for the IT department to do, and they can't get to all of them. So there's a giant list of projects that even go undone because there's no funding to complete those. At the right on this slide, there's a pie chart that shows you why projects fail. It's a bit of an eye chart, so I'll read it to you. Incomplete requirements, 13%. Lack of user involvement, 12%. Unrealistic expectations, 10%. Lack of executive support, 9%. Changing requirements, 9%. and lack of planning, 8%. The remainder is a miscellaneous category with many different types of problems, including didn't need it any longer, lack of IT management, or technology literacy. There's a famous consulting company that does a chaos report every year, and it reports on how many IT projects are successful, challenged, or failed. So successful is really great, and you can see from this chart in 1994 that the percent of successful projects that the chaos report concluded were done was 16%. That's a very, very small percentage. But the good news is the percentage is increasing, and if you look at 2009, 32% of IT projects were successful. The scary statistics are those that failed. In 1994, the Standish group claims that 31% of IT projects failed. In 2009, 24%. That's a quarter of IT projects failed. That's a huge number. It doesn't inspire confidence from users. I came across a article recently on ziffdavis.net, Does Standish Have It Wrong? And they said that maybe the measurements that the Standish group is taking are flawed because they survey executives instead of program managers. And a program manager, the person who's really managing the project, might have quite a different view of what the challenges are and why the project is failing. ZDNet also suggested that we look at the challenged projects and figure out what is the problem, not just call it a challenged project. If the funding's cut, the IT group can't very well produce all of the requirements needed to make the project a success, so it might be beyond the control of the IT department. So that happy picture is what program management or project management is all about. There's several reasons why projects fail, very intricate reasons, and usually it's a political or a human reason, not a technology reason. So great project management, hiring the right person to run your project is worth all the money you can spend on that person because they can bring your project to success and they can bring it in on time and on budget. So the characteristics that lots of different sources say are great for a project manager are be a communicator. Of course, you've got your workers, you've got your upper management, you've got your end users or your clients, and you've got to be able to communicate project goals and problems and successes to these constituencies all the time. The person needs to be organized. Of course, that's a no-brainer. If you have a complex project, a lot of organization is required. Foresight. A project manager with the right amount of experience can foresee a problem before it occurs. If they can see this group isn't getting enough time to do their work, and then you cut the test schedule so that you'll meet the goals, then you know there's going to be a problem in test, and test needs more time, and you can do something to try to fix that before it becomes a problem. Leadership, being a leader and having people respect you and listen to your ideas and follow what you say, very important. Pragmatic. A project manager needs to be pragmatic. If you've got designers and programmers and engineers that want to put everything into a project that is way beyond scope, it's going to cost you a fortune and your project's going to be delivered late. Any added complexity is going to also cost you time and money and open up a big chance that you'll create errors and that'll cost even more money. So a pragmatic project manager can keep these people focused on meeting the user's needs and not going outside the scope of the project. Project management is such an important issue that there are now certifications that people can earn in project management. You've probably been on LinkedIn. You've probably seen next to several professionals' bios, it indicates that they have a PMP certification. To get that certification, you take an exam. And the minimum requirement for taking that exam is that you have a 4-year college degree, 3 years of program management experience, and 4,500 hours leading and directing projects, and 35 hours of project management education. So it's a very serious certification, but it looks really good when you're looking for a job because it shows you have the experience and the skills necessary to be a good leader and a good project manager. So we looked at why IT projects fail. Now let's look at what makes an IT project successful. Upper management support. If upper management isn't interested in your project, then maybe you should find something else to spend your time on, because without support, if something goes wrong, management's going to say, well, this is a bust, and not support you and not give you the resources you need to make that project a success. User involvement. You have to know what your clients or users, what the people that are going to use the information system, what they think of it, what their needs are. And the way you do that successfully is to involve them very early on and make them part of your team so that you know what their thoughts are early on and so that they don't get blindsided or surprised by anything that you're developing. Communication. Again, communication is the biggest thing you need to do to make things succeed. Clear, complete requirements. And you know what? You're never going to have this. The requirements will always have some ambiguity. There will always be a missing requirement. There will always be some problem with requirements. But the closer you can get to perfect, the better off you are further down the line. Because if you miss a requirement or you make a mistake early on, fixing it after 2 months worth of development is a lot harder than fixing it in the first place and never having to rework what you've already done. Appropriate staffing. If you don't have enough people to do the work, then your project's going to be late and those problems are going to snowball and continue to plague you till the end of the project. Manage change. All projects have change. People quit, requirements change, the client changes their mind. And if you're good at managing change, it will add to project success. Track and communicate progress. It's really important to know what your deadlines are and how close you are to meeting them. And then manage client expectations. Don't promise them the moon and then deliver Barstow. In project management, there's said to be a triple constraint: time, money, and scope, where scope really refers to the size of the project or the requirements. The requirements are the size of the project. If any of these things change, the project changes, right? An increase in requirements is going to cost more money and take a longer time to develop. If you get your budget cut, less money means that you can't deliver everything you had planned. If you have a shorter timeline, you have less time to produce the project, it probably means there's going to be less functionality in the final delivery. Often IT departments have a project portfolio. Typically, there are more projects to do than an IT department has resources for, so you need to wisely choose what projects you're going to spend your time and money on. So you have a portfolio, a selection of several projects that you're going to promote that meets your organizational objectives. So you might base your first criteria on cost-benefit analysis. Is the project going to save money or make money? Is it going to be successful? Potential for success. Is it a super risky project? It might be. It might be good to do a super risky project because it might leapfrog you into making even more money. But it might also be that in your portfolio, you need low risk projects, say 80%, and then 20% risk projects. It depends on what industry you're in. Political support. Is it something that management cares about and is willing to support you in? Efficiency and effectiveness. Does the project do a good enough job increasing efficiency or effectiveness that it has a good ROI? Another thing that might encourage you to do a certain project is to build the skills of your IT staff. If it's a new technology and your team doesn't have that skill yet, doing a low-risk project that uses that technology might better position your IT group for future development. Project management tools, and probably since you're in the College of Business, you're pretty familiar with a lot of these anyway. So the classic tools that we think of as things project managers use are work breakdown structure, WBS, a Pert Chart, which shows critical path between project milestones, and then a Gantt chart, which shows you a top-down grid of all the activities that are going to make your project go. Other tools that help the program manager might include workflow or financial reporting. Project documents. There's a lot of documentation that goes with projects, though modern methodologies like Scrum try to get away from the documentation, but still, these are things that help you set up and run your project. Before your project even starts, you might have an RFP, request for proposal. In the request, the client or the government or someone who wants you to develop software for them is giving you the requirements, what their vision is for what they want, and they'll give you an estimate that you have to write a proposal for to meet their needs. Then in a competitive bid, many contractors will submit their proposals and hopefully they'll pick yours because it was brilliant or it was low cost. After the RFP, you sign a contract, and now your company has a relationship with another to produce the system or the software. After the contract's developed, you have what's called a work breakdown structure, or WBS, and this delineates all the work that you're going to be doing and gives numbers to it that are going to feed into your accounting system and let you know how much you can charge, how many hours, how much it's going to cost, and how much your employees are going to be charging towards that contract. Then shortly thereafter, the requirement specification is built, and a requirement spec delineates all the functionality, all the requirements, all the physical requirements, software requirements, everything that you could think of that is related to the system that you're producing. And that's your beginning design document for the entire project. As you move along the systems development lifecycle, you'll go through design reviews, but it'll always tie back to your requirements. Does the design meet the requirement spec? Then you'll move to test. Once your design's over, you'll do testing and quality assurance, and you'll go back and say, did we meet that requirements? Does the system do what we planned for? This is a sample WBS. It's for building a robot housekeeper. I don't know why that's in my brain. It just was. Okay, I do know why it's in my brain. Robot housekeeper. And it probably would be a 10-year development with 30 engineers working on it the whole time. But I chose 90,000 hours and I said $10 million. Probably it would be more like $500 million to get one that really did the mopping the way you want and scrubbing the toilets and maybe feeding the dog. Then you can see there's a 1.0 right next to it. And we break that down into smaller tasks. So in 1.1, I've got requirements, 4,000 hours, who knows how much money. 1.2 is analysis, 1.3 is programming, 1.4 is integration and test, and it's got hours and dollars associated with it. And I broke analysis into my different subsystems for the robot. I've got the communication subsystem, so the robot can talk to the other subsystem, so that I can talk to the robot, so that the robot can fix itself. I've got a mobility subsystem, so the robot can move around and do all the chores. I have an electrical subsystem, so that the robot has power and it can figure out when to plug itself in. And I have a cleaning subsystem, the most important one, so the robot can figure out what it needs to do to clean my house. Okay, I'm off topic. It really has nothing to do with the robot. It has to do with WBS divides the tasks hierarchically into subtasks and shows you how you're going to spread your money all throughout the contract. This is a Pert chart. I'm not sure if it looks like Pert charts that you've seen before, because usually those are generated from Microsoft Project or some cloud-based project management tool. This Pert chart shows the subset of the project leading up to the design review for the robot communication subsystem on 4/19/2013. It's just a subset. It's not the whole project, just the robot communication subsystem. So after 4/19/2013, it's going to go to integrate with mobility subsystem because, right, I can't have communication with no mobility, and I'm going to have several integration phases to pull the different subsystems together. So a lot of times when you're using a Pert chart or when you're doing project planning, you know what your delivery date is and you work backwards from there. So if I go back from the design review, I know that I've got to have integration and test of all the different commanding systems. User interface commanding, smart mobility, cleaning subsystem commanding, and state of health commanding all have to feed into integration and test, where we're going to pull the command center together and then test it to make sure all the functionality's there. But before each one of these commanding subsystems is developed, it's got to go through its own separate requirements, analysis, programming, and test phases. So you see in light green these little phases that lead to that. So the critical path in this picture is really integration and test of the commanding subsystems, and also the design review, really a milestone, but all those different subtasks lead into this big task. So if I have a big problem with state of health commanding and it's going to be 3 months late, that's going to make integration and test 3 months late, and it's going to make the design review for the robot comm subsystem 3 months late also, and propagate throughout the tasks throughout the program. Not a happy thing. This last project management tool is called a Gantt chart. You're probably already familiar with it. In it, I can see every task that I need to do to accomplish my project, and across the top, I see the weeks 1 through 13. not long enough for robot made, but a big project nonetheless. And I can tell visually how I'm doing on my different tasks. So if I look at the first thing, summary element 1, the black represents how much I've completed and the blue represents how much I have left to do. And I can see that I'm only 57% complete. The dashed gray and white line that's labeled with today represents what today is in history and how far behind I am. You can see with these lines how much you've done and how much you should have done. So during week 7 and 8, in between those 2 weeks, I should have been with my black line right up to that project line. If I look further down on the project, I can see that WBS summary element 2 is not started at all. It is 0% complete. This is really delaying what I need to do. Quiz time. Why is everyone so spun up about IT projects? Why is everybody so upset? Because it costs money. And IT has a history of overrun projects that are late and the clients are unhappy with the performance. So people are really upset about IT projects and they really want to control cost. What is the triple constraint? Time, cost, and scope or requirements. If any one of these changes, the other two have to change also. What is an RFP? Request for proposal. It's what people send out that you can bid on to try to win work for your company.